Now let us consider the remaining case where there's no linear factor. Degree 4 split into at least two parts where each of them has degree at least 2, then this is the only case. So the first factor is degree 2 and second factor is degree 2. The even simpler case that we're about to consider here is that these two degree 2 factors are actually equal to each other. So original polynomial in expanded version looked like this. So this is a given polynomial with integer coefficients, and what we want is this one factors into this shape, x squared plus bx plus c, that entire thing squared. So this is what we want to check. So I wrote down the polynomial 2 times like this, and together with you we're going to actually multiply it out and see how these two coefficients compare. And you will see there's a fairly quick way to check if these two 5 given coefficients actually fit into the coefficient we have it as we expand these two quadratic polynomials. I think the first collection we're going to look at is the coefficient of x to the fourth part, and you can see degree 2, and this is the only possibility. A squared is the only possibility. Let's think about not knowing what's going to go in there. Let's think about all the degree 3 cases here. So degree 3 cases, let me use the blue, degree 3 cases can come from this degree 2 and degree 1. That's the one case here, so that will give us a times b. And maybe we can have this degree 1 case and this degree 2 case in here. So about that. So here's a degree 2 case, degree 1 and degree 2. So that's another case, so here's AB. So altogether 2AB is the coefficient of x cubed. Now let's check the case of degree of x squared. I'm going to use a green for this one. How do we get x squared? You can multiply this ax squared with this c, which is constant, so together it's going to be ac. And of course another way from here to get an x squared is this c here down there and paired with this ax, so there's another ac kicks in. One more possibility that we didn't have for the third case is that multiplying this bx times this bx right here. If you multiply these two, we also get x squared, so we have a b squared kicks in there. Now next part is a degree, a coefficient of x. There are not many possibilities of a coefficient of x, so maybe we can just do this in here. This bc, as you can see, is multiply this bx to the coefficient, constant part, excuse me, that's going to be bc here, and as you can see, c is multiplied to there, that's another bc. That's the coefficient. And let's look at the constant part and then c squared. So that's how it's going to unfold. Let's put them together. That part is a squared x to the fourth, and this second coefficient is 2ab x cubed, and the third coefficient here is a 2ac plus b squared x squared, and this coefficient is a 2bc x plus c squared. So these are the shape of the coefficient. Remember that we have 3 coefficients to determine. It's fairly easy to check whether this is going to be satisfied. If you're looking at a polynomial a and e in there, this a must be a perfect square and e must be a perfect square of an integer. If that happens, then we have a choice of a and c. So the first condition we have to satisfy is that a and c are perfect squares. Then from there we have 2 choices, that a being positive negative square root of a, that we have it there, and c being positive negative square root of that's little c, and that's capital C, capital E in there. We have capital C in there. I'm just going to use hook to distinguish that. So we have these 2 choices. These are integers after you put the quadratic square root. So this pretty much determines the choice of a and c, but we have some choices to make, and a and b to be whatever the sign that we have to combine. Next part is the b, but if you look at this coefficient of x cubed, is easy. You can easily determine what the b has to be once you have this a and c is selected. So there are four possibilities. If you choose some of those and b had no choices, the b little b has to be the coefficient of x cubed. Here's a capital B, the capital B divided by 2a in there. That 2a is one of the choices we have made. So if this works, a and b and c had no choices but must be this one. So I'm going to summarize it over here and go through our little exercise. So here's an example that you try all the rational zero theorem and realize it, and this doesn't have a solution. Means it does not have a degree 1 rational factor or rational zero. Then the possibility is the factors degree 2 and 2. Then first thing you're going to try is maybe it is a perfect square of a degree 2. So it has to fit into this pot. First thing you notice is that the coefficient of x to the fourth and constant are both perfect square. So it's in this case. Otherwise, we have to look at the general case of these two. The degree is different. So let's try the case where so little a is a positive 2 and c there's a positive 3. Those are square root of the coefficient of x to the fourth and a constant part. Then it had no choice that the little b must be the coefficient of negative 4. That's a capital B, the coefficient of x to the third, divided by 2 times a, which is 4 here, so that's negative 1. If this works, and this is the only possibility. So we're going to look at the polynomial 2 times x squared minus x plus 3 squared in there. So we actually expand it and see everything fits in perfectly. Just like we expanded to get this relationship between these uppercases, the coefficient, and lower. Sorry about the interruption, but so this is the possibility. So if you actually expand it, you get this entire coefficient back. Let me give you a slightly different example and compare it with this one in here. So this is example and where these a and c are exactly the same information. So write down here a is 4 and c is 9, and even b you get here is the same. That is exactly from a, only b only requires this a and the coefficient of x to the third. So in this case we're going to try a equals 2 and c equals 3. From there b is going to be negative 1, just like we did before. But if you try 2x squared minus x plus 3, and if you square it, you don't get this one back. It turns out it's wrong answer. And what went wrong is that nothing went wrong. We didn't try all possibilities. So you can change one of the sign, a being 2 and c being negative 3, or a being negative 2 and c being 3. Since these things are inside the square, trying only one of this possibility of a sign combination will be actually sufficient. So realize that this doesn't work, and next thing we should try is a is 2 and c is negative 3. This is opposite sign. B is only determined by the value of a and the coefficient of x to the third, so this is going to be the same, negative 1. So this time, let me write it over here, if you try 2x, continue here, 2x squared minus x minus 3 squared it, and then you get that correct answer, the correct answer back. So this is probably the first thing you want to try, or second thing you want to try for the case, this 2 plus 2 case in here. So next example is also very, very simple. With after trying these two methods, if it doesn't work, you have to move on to the very last case where this is completely different and complicated.